Dear students, Assalamu alaikum. Welcome to this channel. Dear student, in the previous lectures we studied about the Coulombs Law, which is given by F is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. This Coulombs Law gives us the magnitude of the electrostatic force between 2 point charges. And from the formula, we can see that electrostatic force depends upon the product of the magnitude of the charges, the inverse proportion of the square of the distance, and it depends upon the medium as well. Now, being a science student, there might be a question in your mind, why these charges exert forces on one another? What is the reason for that? Newton gave the law, gravitational law, and its formula was F is equal to G m1 m2 over r square. This is the formula for the gravitational force, approximately the same. But he could not give the reason of this gravitational force. What is the reason for this? And similarly, Coulomb could not give the reason for the electrostatic force between the charges. Both of them just found the magnitude of the electrostatic force between just the magnitude of the electrostatic force. Coulomb for between the charges and for Newton's between the masses. And they used almost the same apparatus that is known as torsion balance. So the question is, why these charges exert forces on one another? So can you answer this? So the answer to this question is that it is still unknown. We don't know the reason of that force between two charges or force between two masses. The reason is unknown. So those forces whose origin is not known to us, those forces are called basic forces. What are the basic forces? The forces whose origin is not known to us. Those forces are called basic forces. For example, gravitational force is a basic force. Electrostatic force is a basic force. We don't know the reason of these forces. Okay? Then there may be another question. How these forces are transmitted while the two bodies, the two masses, the two charges are not in contact with each other, then how they can exert forces on one another? So the question is how these forces are transmitted. So to answer this question, we suppose a charge. Let's suppose here we have a charge. Let me call this charge as Q. Now we know that the charges exert forces on one another. Okay, for that we bring another charge. We bring another charge. Suppose here is another charge. Let me call this charge as Q naught. If I place this charge Q naught at this position, suppose it does not experience any force. While charges are there, but it is not experiencing any force. Then I move this charge Q naught closer to this charge Q. Suppose I reach at this position. Again this charge Q naught does not experience any force. Then I move this charge Q naught further closer to this charge Q. Suppose when I reach at this position, this Q naught will start experiencing the force. It means that this electrostatic force is a kind of force which you may call as action at a distance force. Because this force exists only when there is certain distance between the charges. When the other charge is at a specific distance from that charge, it will experience the force. If this charge Q naught is farther from that position, from that specific distance, then it will not experience the force. So whenever you will be at this much distance from this charge Q, suppose, then this charge Q naught will experience the force. So suppose if charge Q naught is here, again if this distance, this much is the distance, and if this distance is same and Q naught is here, and it will experience the force again. And if it is at this much distance again from this side, it will again experience the force. So around this charge, if Q naught is at this much distance from this charge in 3 dimensions, then this charge Q naught will experience the force. So this region of space around this charge, in which this charge Q naught, the other charge, is experiencing the electrostatic force due to this charge Q. This region of space around this charge is called electric field, a concept given by Michael Faraday. According to Michael Faraday, it is the intrinsic property of nature that a field exists in a space around the charge. This field is responsible for the transmission of this charge, for the transmission of the force. So electric field is also known as force field. Why force field? Because due to this field, the force is transferred from one charge to another. Now we are in a position to define electric field qualitatively. So electric field is defined as the region of space around a charge in which the electrostatic force due to the charge is experienced by other charge or charges. This is the definition of electric field qualitatively. Okay, next is, can we check the electric field around a charge? So for the checking of an electric field, we bring a charge, another charge, closer to that charge. If that charge experiences a force, it means that it is in the field of that charge. So that can be checked by using another charge. Now again another question, can we measure the electric field? So yes, we can measure the electric field. Why? How? Because we can measure the force, so we can measure the field. Because as it is force field, we can measure the force, we can measure the electric field as well. So to measure the electric field, we define this electric field quantitatively. So quantitatively, this is called electric field intensity or electric field strength. So we define this electric field intensity at a point as the electric field at a point is the force experienced by a unit positive charge usually known as test charge at that point. So to measure the electric field at any point, just bring a test charge at that point, and the force experienced by that test charge will give us the magnitude, the strength, the intensity of the electric field at that point. Mathematically, we can write this as E is the representation for electric field, is equal to F by Q naught, and this Q naught is called as unit positive charge, or usually we call this as a test charge. So what is a test charge? So test charge is a charge whose magnitude is very small, so that it may not affect, it may not distort, it may not disturb the field of the charge under observation. So from this formula, if we find the SI unit of electric field, so the unit of electric field becomes, the unit of force is Newton, and the unit of charge is Coulomb, so this becomes Newton per Coulomb. This is the unit of electric field. So what is the nature of this electric field? What is the nature of this quantity? This electric field is a vector quantity, and the direction of this electric field is in the direction of the force, because the formula E is equal to F over Q naught. If F is a vector, then this E is also a vector, and the direction of electric field is in the direction of electrostatic force. Now students, we derive a formula for the electric field at a point due to a point charge. Our next topic is electric field at a point due to a point charge. So for this, we consider a point charge. Let's suppose here is a point charge Q placed at a certain position O, suppose, and we are supposed to find out this the electric field of this point charge at this position. Let this point is P, where we're gonna find the electric field of this point charge. For this, we bring a test charge Q naught at this position, because to check an electric field, we have to bring a test charge. And according to the definition of electric field intensity, it is the force experienced by the unit positive charge. So to find the electric field intensity at this point, we place a unit positive charge or the test charge at this position. Let this point P is at a distance R from this charge. So this charge Q naught will experience a force. Now if I suppose this charge to Q to be positive, then this Q naught will experience an electrostatic force of repulsion. And what is the direction of the electrostatic force? Is along the line joining the 2 point charges, as you know. So this is the direction of the electrostatic force experienced by this charge Q naught. Let me represent this force by F. Now what is the magnitude of this electrostatic force which this charge Q is exerting on Q naught? So yes, according to Coulombs law, this force is F is equal to 1 over 4 pi epsilon naught. The first charge is Q, the other charge is Q naught, and the distance between them is R. So this is the magnitude of the electrostatic force between these two charges. If we write this formula vectorially, then we have to multiply this magnitude with the unit vector, and the unit vector is in this direction, the direction of force. So this is the unit vector, this becomes a vector. Now using the definition of electric field intensity, E is equal to F over Q naught. Now putting the value of F in this formula, So E is equal to 1 over 4 pi epsilon naught Q naught over R square, here is R square, divided by Q naught into unit vector R. Now you find that Q naught and Q naught will cancel out. Why they cancel? Because Q naught was a test charge and its purpose was to check the electric field. So the influence of the checker should not be in the final result. That's why this Q and Q naught will cancel out. Now the formula for electric field at certain point becomes E is equal to 1 over 4 pi epsilon naught Q over R square into unit vector. This is the formula for the electric field intensity or electric field at a point due to a point charge. So we have found the electric field due to this charge Q at a distance R from it. Now finally, just look at this formula. From this formula, we can see that this electric field of a point charge depends upon the magnitude of charge. The greater the magnitude, the stronger is the electric field. And number two, this electric field varies. How it varies? It varies inversely as square of distance. It varies inversely as square of distance from the charge. That is, electric field obeys inverse square law. It depends upon the magnitude of the charge. It depends upon the distance from the charge, and it varies inversely proportionally as square of the distance. And thirdly, what is the third thing in it? That is the medium. It depends upon the medium. So if there is a medium around this charge, then that electric field will also change. The intensity or the magnitude of that electric field will also change. Magnitude of that electric field will also change. So if you are using a medium around this charge, then the magnitude of this electric field becomes E is equal to 1 over 4 pi epsilon Q over R square. And as you know that epsilon is equal to epsilon naught epsilon R. In the previous lectures we have studied that epsilon naught is the permittivity of that medium. So the formula for electric field, when there is certain medium between when there is certain medium around the charge, then E is equal to 1 over 4 pi epsilon naught epsilon R Q over R square. So this is the electric field when there is a medium around this charge, and this is the formula for electric field when there is vacuum or no space, no medium around this charge. Again, if we compare these two formula, this one and this one, then we come to the conclusion that electric field when there is medium is equal to 1 over epsilon R times is the electric field when there is vacuum, same like the electrostatic force. So students, in this lecture we have studied about the electric field, and then we derived a relation for the electric field due to a point charge at a point.